we have questions about Dawn's visit to Ceres. How long will Dawn stay at Ceres? And you were speaking about shape just before. Will Dawn have any instruments that will be able to measure exactly how round or spherical Ceres is?
Yeah, that's a really good question. So Dawn will be at Ceres right now. The nominal mission's about 5 months. The thing about it is that Dawn has had some difficulties, and so we'll probably be staying at Ceres. Like it's not, we're not going to leave and go somewhere else. But what that means is that we'll probably get more time, hopefully, at Ceres. Now, there's all kinds of factors that go into that, but the initial mission plan is about 5 months there. But if you remember what happened with Vesta, you know, we had about 9 months planned at Vesta, and then we ended up staying longer, a little over a year. So Ceres, I mean, no decisions have been made about what Dawn will do, but the nominal mission plan is 5 months at Ceres, and if the spacecraft is still working, you know, we'll still be working on it too. Most missions that are still successful and still operating end up continuing, so it's probable that we'll get more and more observations at Ceres. That all depends on lots of decisions, so none of that's actually been made for now. So for now, we know we have 5 months about. And 2 different orbital phases, a high altitude orbit, well actually I guess 3. There's a survey orbit, and then a high altitude mapping orbit, just like at Vesta, a little further away than it was at Vesta, and then a little bit of a lower orbit, and that one's also a little higher than it was at Vesta. But we're hoping that we'll have some more time in a working spacecraft at the end of that nominal mission so that we can extend it and be able to do some more science. That's, of course, getting ahead of oneself, so for now we're just planning for that nominal mission. But you were saying, you know, are we going to be able to measure Ceres shape? Yes, of course we will. One of the things we can do when we're starting to come in is we'll actually be taking observations of Ceres, mostly using the cameras and then, of course, with the spectrometers. But we use those cameras and lots of rotational images to be able to get a great shape model. You know that you've probably seen the images, and if you haven't, you should check them out, of the shape models of Vesta. Those are all made using using the cameras on board Dawn. So we'll get just as good a shape model probably for Ceres, and that'll be constructed over the first part of the mission. So we'll get lots of opportunity to see that. And that's really important because we'll get a really accurate measurement of its mass as well. You know, right now we know how much Ceres weighs, if you want to put it that way, by its interactions with other asteroids. So it goes by Mars or it goes by another asteroid, and it kind of tugs on them a little bit. And based on how much it tugs those things out of orbit, that's how we know how massive Ceres is. However, when we get there with the spacecraft, we'll actually be able to look at how Dawn is flying and record that data, and that's actually part of the gravity science. So when you think about gravity science, you know, there isn't a gravity detector. You don't like send gravitons out and try to get the weight of the planet. But when we get there, we'll actually be able to let Ceres, basically let Ceres tug the spacecraft around. And how that happens is how we know the mass and the mass distribution inside the asteroid. That's really cool because that'll be actually how we can tell how much ice is there. Where is it located? The way that you do that is based on density contrast. So if I'm holding a piece of iron and a glass of water, those are very different densities. And so the spacecraft, based on the orbit of the spacecraft, we can actually tell where the water is inside of Ceres. Now, we won't be able to tell if there's an ocean or not. We'll have maybe some indirect evidence, but we will be able to tell that there's ice or an ice water layer there.